Hello everyone. So this is the summary on the lesson 7.2 Theoretical and Experimental Probability. So first of all, let us go through what is probability. Probability is the measure of how likely an event is going to occur, and each possible result of a probability is known as an outcome. And then all the outcomes together, all the possible outcomes together make up the sample space. So these are the terms we need to understand from here. What is an outcome? What is a sample space? And what is an event? An event is an outcome or set of outcomes. So let's explain it with an example. Here, the event in the first situation is rolling a number cube. So we are going to roll a number cube. That's the experiment or the event. The sample space is all the possible outcomes we'll get by rolling the number cube, which is the numbers 1, 2, 3, 4, 5, and 6. So these are our possible outcomes. We can get either the number 1, 2, 3, 4, 5, 6. In the second case, spinning a spinner is the event. The possible outcomes are red, blue, green, and yellow, and all these outcomes together make up the sample space. So this whole thing together is known as a sample space. So probabilities are written as fractions or decimals from 0 to 1. So that means whenever we describe a probability, it's going to be a number between 0 to 1. That means if I have probability of a situation where it is more than 1, that means it's wrong. We can identify in certain situations when you are solving, if you get the probability value more than 1, it means your answer is wrong. Yes, when you are writing it in percentage, then it can go from 0 to 100%, of course. But in terms of normal numbers, we write it from 0 to 1. That means it can be either a fraction like 1 over 2, 1 over 3, etc., or it can be a decimal 0 0.5, 0 0.6, etc. So it should be a number between 0 and 1, or in percentage, it should be between 0 and 100%. Now, when the probability is 0 or 0%, that means the chance of that thing happening is impossible. So we say something is impossible when the probability is 0. And if I have the probability of an event as 1 or 100%, then we know that it's guaranteed to happen. So it is a certain situation. It's confirmed that it will happen. And we have, if we have the probability 1 over 2, which we normally tell as 50-50. So that means it is as likely to happen as not. So that means there is a 50-50 chance of something happening and it not happening. So this is how we describe the three ranges of probability. So impossible and certain are the two extremes, and in between we have as likely as not. Then what are equally likely outcomes? Equally likely outcomes means they have the same chance of occurring. For example, if we take a number cube, we have the numbers 1, 2, 3, 4, 5, 6. And all these numbers are only one time on the cube. That means each number has a 1 over 6 probability or chance of coming up. So each number has the exact same chances of coming. So for the number 1, we have 1 over 6. The number 2, the chance of it coming is again 1 over 6. Okay, and so for all the numbers on the number cube. When you toss a fair coin, so on a coin, you have one side is heads, one side is tails. So whenever you are tossing it, you have 50-50 chances of each. That means they have equal chances. The heads and tails, they have equal chances. The same goes for these numbers. So these all have equal chances of coming up. There is no biasness. So let's say if I had on a number cube 1, 2, 2, 2, and then 3, 4, then the chances of getting a 2 would be more. Then it is not equally likely. That's a condition where it is not equally likely. Equally likely means all the outcomes have the same chance of occurring. Now, favorable outcomes are outcomes in a specified event. So whatever the event is specified, favorable outcomes means the outcomes that I want to happen or to occur in the event, that are my favorable outcomes. For equally likely outcomes, the theoretical probability of an event is the ratio of number of favorable outcomes to the total number of outcomes. So in theoretical probability of an event for an equally likely outcomes, okay, the number of favorable outcomes, the ratio of the number of favorable outcomes and the total number of outcomes will give you the theoretical probability of the event, which is this formula. So probability of an event is equal to number of favorable outcomes divided by total number of outcomes or number of outcomes in the sample space. Explaining example 1, each letter of the word probable is written on a separate card. So these are the letters Probable is written on a separate card. The cards are placed face down and mixed up. What is the probability that a randomly selected card has a consonant? So we all know about vowels and consonant in the English alphabet. So in this example or in this word probable, which are the consonants? So P is a consonant, R is a consonant, O is a vowel, B is a consonant, A is a vowel, again one more B, so again consonant, and L is a consonant, E is a vowel. So the question is, what is the probability that a randomly selected card has a consonant? So we need to find the probability of this. So there are total how many outcomes are there on the sample space? All these letters of the word probable are the possible outcomes. So Probable, there are 8 outcomes and 5 are favorable. Favorable are the consonants. So 1, 2, 3, 4, 5. So we have 5 favorable outcomes out of total 8. So we write P of consonant, that is the probability of consonant, is 5 out of 8. And in terms of percentage, you can just multiply 5 out of 8, multiply this with 100, and you will get the answer in percentage. Next we have 2 number cubes are rolled. 2 number cubes are rolled. One is a red color number cube and the other is a blue color number cube. What is the probability that the difference between the two numbers is 4? So when we roll 2 number cubes, how many outcomes are possible? If we use the fundamental counting principle from our previous lesson, we know that for each cube there are 6 possible outcomes. So 6 multiply with the other cube 6. There are 36 possible outcomes, and it's given here that all the outcomes. So 1 with 1, 2, 1 with 2, 1 with 3, like that, and same with 2 with 1, 2 with 2, etc. We have, these are the total, all the outcomes. There are 36 outcomes here. The question says probability that the difference between the two numbers is 4. So I have to check here which two numbers, if I subtract, will give me 4. So in the first row, I can see 5, 1 will give me 5 minus 1 is 4. Then here I have 6 minus 2, which will give me again 4. In this one we don't have the third one, so this one also we don't have. Again we have here 1, 5 and 2, 6. So there are 4 favorable outcomes. How many total number of outcomes we have? 36. So probability that the difference, there are 36 possible outcomes, and probability that the difference is 4 is number of outcomes with the difference of 4 divided by 36. So we have 4 outcomes: 1, 5, 2, 6, 5, 1, 6, 2. These are our favorable outcomes. So we have 4 out of 36, which if we simplify, we will get 1 over 9. This is very similar. The sum is 6. So check your outcomes. There are 5 outcomes in this case. So 5 out of 36. And similar questions. The sum of all probabilities in the sample space is 1. What does this mean? So let's say if I take the different numbers of a number cube. So we have 1, 2, 3, 4, 5, 6. So each of them have a probability of 1 over 6. So if I take the probability, the total probability of all the numbers, if I add them up, I will get the total as 6 over 6, which is 1. So that is what it means. The sum of all probabilities in the sample space is 1. The complement of an event E, so this is for the case that I will get any of these numbers on the number cube. If I add them up, the sum is 1. We can have similar case for any other event. The complement of an event E is the set of all outcomes in the sample space that are not E. What does this mean? So let's take an example. Probability of getting a number more than 1 would be, we have, in case of a number cube, I'm saying, sorry, probability of a number more than 1. So we have the numbers 1, 2, 3, 4, 5, 6. Okay, probability of a number more than 1. In general, I can say, okay, there are 1, 2, 3, 4, 5 numbers which are more than, so I'll write 5 out of 6. But instead of writing this, I can also write it in another way, that probability of a number more than 1 is also 1 minus probability of a number 1. So 1 minus, what's the probability of number 1? 1 by 6. So total will get 5 over 6. So this is just a simple example. We can use this. This is known as the complement of an event. So probability of a number more than 1 is 1 minus the complement of the event. So this was the event, and this is the complement of the event. Complement basically means the outcomes other than that of the event. So here if you see, probability of not E is equal to 1 minus probability of E. So probability of getting not E equals 1 minus probability of E. We can explain this with a proper example here. Let's say this example, there are 25 students. So first statement is here in a study hall. The table shows the number of students who are studying a foreign language. So this table is showing students who are studying foreign language. What is the probability that a randomly selected student is not studying a foreign language? So these are the students who are studying foreign language. So how many are there total? 6 plus 12 plus 3. It is 21. So 21 students are studying foreign language. Out of how many students? 25. 21 students out of 25 are studying foreign language. Then how many of them are not studying foreign language? So this is probability of foreign language. The students who are studying foreign language is equal to 21 out of 25. So if we see here, probability of not studying foreign language is equal to 1 minus probability of studying foreign. So which is 1 minus 21 over 25, which is 4 out of 25, or in percentage we can write as 16 percentage. So for simple questions, it might look less useful, but if we have a large sample space, then this can really help. So two integers from 1 to 10 are randomly selected. The same number may be chosen twice. What is the probability that both numbers are less than 10? So, I mean, less than 9. Both numbers are less than 9. So, how many numbers we have less than 9? So, we have from 1 up to 8. So, there are 8 numbers that are less than 9. We know that. But instead of doing that, I can take 1 minus probability of number more than 9. So how many numbers? So probability of a number less than 9 equal 1 minus probability of number more than 9. So how many numbers are there more than 9? More than or equal, sorry. More than or equal to 9. So there are two numbers, 9 and 10. So 1 minus 2 out of 10, which will give me the answer as 8 out of 10, or 4 over 5. So for one number, it is, there are two integers. So for one number, for one integer, it is 8 out of 10, or we can say 4 over 5. Okay, that's for one number. Now there are two integers. So for getting the total probability, I need to multiply their individual probabilities. So probability of one number is 4 over 5. So probability of both the numbers are, and as I said here, the same number can be chosen twice. So they have the same probability for both. So we have 4 over 5 multiply with 4 over 5, which will give us 16 over 25. In example 3, we have finding probability with permutations and combination. So the question says each student receives a 5-digit locker combination. What is the probability of receiving a combination with all odd digits? So first thing we need to notice here is it did not say us that the number cannot be repeated. Whatever the number we choose, it cannot be repeated. So, and don't get confused just by reading this combination as the question is of combination. No, it's not. Okay, so in this case, first of all, we need to check how many total outcomes we can have. So it's a 5-digit locker. So that means there are how many total outcomes are possible. So each digit has the numbers from 0 to 9, so 10 possible outcomes. Since they did not say that we cannot repeat the number, so that means we can repeat the number. So it will be 10 multiply, which is 10 to the power 5. Okay. What is the probability of receiving a combination with all odd digits? So this is my total probability. This here is total outcomes. Sorry, not total probability, total outcomes. Total possible outcomes. Now my favorable outcomes will be favorable outcomes would be, so again we have 5-digit locker combination, but the question says receiving combination with all odd digits. So how many odd digits are there from 0 to 9? There are 5 odd digits. So the numbers 1, 3, 5, 7 and 9. So 5, 5, 5, 5 and 5. So how many, what's the answer here? So 5 to the power 5